before Dr. Gofman starts here, I'd like to give you a brief introduction to Master Software Engineering program with the handout that I gave you. So if you can look at briefly, it's going to take a few minutes before Dr. Gofman does the presentation. So, all right. So I'm the coordinator for this particular program, Master Software Engineering program. So what are the slides are really small, so you need to look at it very closely. First of all, look at the what are the needs, what kind of things, skills you need to have in order to become software engineer. So I have listed a few of them which are very important, I think. Obviously, first of all, you have to know the development part, from requirements analysis to design and testing, all these skills you have to know. And also, not only the product itself, develop the technology itself, but you have to know also the process and how you develop it. So the process is important. And also, we have to know these days, many projects taking place in terms of groups. You have to work in teams. So therefore, you have to be communication skills, written or orally. It's very important. Perhaps you know, some of you know this. And you have to also, you should be able to also learn new technologies very quickly. So adapt new technology. So these are skills that you need to become a really good software engineers. I'm not sure whether you knew this, we have this program or not, but we have a massive software engineering program. We have two different kinds of massive software engineering program. One is online, the other one is the in-classroom version. The one I'm advocating at this point is the online version. So, which is basically you are laying good foundation for good analysts. You have to be really good analyst to analyze the problems and try to come up with a general solution, which is like good architect. And also we're emphasizing was becoming a good project manager and also working. So our MSc program is here to basically have a good software engineers with a good foundation of these skills. And we have if you look at this slide number 4, we have 10 courses in master's program, which is about 30 units. So you start with requirements and validation, maintenance, process, architecture, project management and measurement, and also legal issues and projects. So we 10 courses, and it takes over 22 months. So just briefly again to mention here, MS is entirely online program. We started 2004. It's 12 years, so we're still here around. I'm not sure whether you knew this or not also, but we're ranked 16th by the US News and World Reports in terms of online programs. And the audience are typically if you have CS background or you have software industry background. So requirement for admission is either you have bachelor's degree in computer science, or if you don't have it, then you should have a equivalent work experience in the software industry. So as you know, there are a lot of people who don't have bachelor's degree but work in the software industry. So both those people are invited also to apply. And again, 2 courses per semester, and 6 to 24 months, and we're currently accepting our application now. So in case you know a friend or friends who may be interested in working in the software industry, they'd like to join this program, let them know, have them contact me, and you can further look at the brochure. It gives some more information on that. So if you're interested in working and getting master's degree at this point, that's also good for you. So that's my commercial before you start. So, okay, now we're very, very pleased to have Dr. Gofman. I think he's very popular to have that lowest thing, I think. Right? If I say student evaluation is like way up there. So, without further ado, I introduce Dr. Gofman here. Please go ahead.
Well, thank you, Dr. Shu. Can I have this program by the way, or is this just for students? He didn't clarify. He didn't clarify. Well, thank you so much. This has got to be the most loading exam ever. But thank you so much. Yeah. Well, thank you so much for coming, everybody. I teach in this room every Tuesday and Thursday. I never saw it this full, so this is very motivating. I hope it'll stay this full for at least the next 30 minutes. I'll do my best anyhow. So today, I would like to talk about malware paper-installed distribution services. That's a mouthful. But let me begin by asking you this question. Who ever had their computer infected by anything they didn't want to have on their computer? That's it. So, where do you think that malware is coming from? Well, what I'd like to talk about today is where most of the malware is coming from nowadays. It's not where you may think it is. I'm surprised that a topic that is this big is being largely neglected both in research community and it's not really being talked about in classes. So, let's talk about what exactly is malware paper installation. Okay, for some reason this keeps skipping me. So, let's talk about how malware was distributed in the old days versus how it is distributed nowadays. So let's begin by defining what a malware is. Malware stands for malicious software. Back when I started teaching security classes, that was in 2007, I had to explain what was a virus, what was a worm. I think doing so right now would be insulting you, so I'll refrain from doing that. Plus, I'm sure a lot of you have gotten one of those folks on your computer. So, one thing you know is you don't want them there. So, distributing malware is a difficult job. After all, if you are a guy who makes malicious programs, you build them to spread them, right? Otherwise, why would you be building them? Well, spreading your malicious software is a difficult job. You gotta find vulnerable systems. You gotta break into them. And what happens after somebody discovers your program and they develop a countermeasure? Now you gotta rewrite the program and you gotta spread it all over again. That's difficult. So what's a practical solution to this? If you are a bad guy, or, well, bad guys don't think of them as bad guys. You're a person who is distributing malicious software. How do you achieve the same task more efficiently? As a software engineer, you always look to optimize processes, right? So, distribution is a big bottleneck. How do you optimize it? Well, the answer is pay somebody to spread your malware for you. So, there is a demand. There is a demand for spreading malware. And wherever there is a demand, there is a supply. And that's where we get to pay-per-install networks. They are groups of people who specialize in distributing malware for the bad guys, and they do it for profit. We'll talk about the malware distribution model and the genius that underlies it. I think it's ingenious because everybody involved in the process benefits. That's what makes the process viable. If everybody profits, the process will keep going. So, and if you're a bad guy, if you have outsourced the task of spreading malware to somebody else, you're now free to develop more malicious software. You have more time to invest in actually making your programs more malicious so you can do more harm. So, we have barely talked about anything, but you can already see some of the implications of pay-per-install services. So let's talk about how malware was distributed in the old days versus how it is distributed nowadays. Back in the old days, most malware is spread by cell propagation. So you get a virus or a worm. So virus would typically arrive in your mailbox as an email. Some of you may be old enough to remember the I love you virus. It made pretty big news back in the late 90s. It came as a Word file which said I love you. Back in those days, people were not as tech savvy as they're right now. So people would open the Word file and it would do all kinds of things on their computer. That was a typical way of how infection spread. Of course, with coming of peer-to-peer networks, that became another popular avenue. You would host a file which has an enticing name. I'm sure you could think of what an enticing name can be. And once you download it, you run it, it's not what you think it is. Or it could be what you think it is, but it also comes with hidden functionality. The main motivation for spreading malware back in the old days was fame. I wanted to be on the news. I wanted my infection to spread far and wide, so I could get a feeling of satisfaction. I could feel like I'm a genius. Fame was the primary motivation. Well, things have changed quite a lot since the old days. Now, the main motivation is profit. It's all about profit. It has very little to do with fame. Now people develop malicious software and they spread them to make money. And as we'll see later on, it is indeed profitable. You could get pretty wealthy by doing this line of work. Not that I'm encouraging you, right? So back in the old days, the self-propagating malware would spread by targeting vulnerabilities in servers. So worms, for example, they would try to compromise email servers so they could mail copies of themselves throughout the network. Back when I was in college, there was a worm called the bagel worm, and it has infected the email server, which would be used for sending emails to everybody in campus. So everybody's mailbox over the weekend was full, so they couldn't receive any more emails. That was the primary way in which malware spread back in the old days. So by targeting server vulnerabilities. Nowadays, things are a bit different. A lot of the server-side vulnerabilities have dried up. People got much better about doing server security. So what happens when the server security vulnerabilities become a problem, when they become scarce? What do? Well, there are still the clients, right? There are still the clients. I mean, think about the kinds of people who run the servers versus the kind of people who run the clients. Who runs the servers typically? Server administrators, right? Which implies a certain level of skill. Who runs clients? Well, if you're using a web browser, that's a web client. You're using an email application, that's an email client. You're using BitTorrent, that's a P2P client, right? So clients are ran by people who are not specialists, and also they have many, many, many vulnerabilities. To really get an idea, just check out your Windows update to see how many vulnerabilities were fixed in, say, IE. I mean, same thing goes for Firefox and Chrome, just to be fair and balanced, right? So let's go back to the big question of malware distribution. I want to distribute malware. I'm an attacker. I want to distribute my malware on the largest scale possible. But what's the problem? I don't have the resources to do it. Spreading malware requires bandwidth resources. It requires a place to store my malware. Plus, it requires time. I need to find vulnerable systems, and I gotta plan my malware. All of this is very time-consuming. It's expensive. It's difficult. So that's where PPI services come in. It's a malware distribution model based on revenue and commission. Attackers rely on a network of people called the affiliates. We'll talk about how that works in a second. But the affiliates distribute malware for attackers. And attackers pay them to do it. Now, PPI is not a novel concept, if you will. It has roots in pornographic and advertising industries. They played that game for quite a while, and PPI networks took a pretty good lesson from that. And they took it to a whole new level. So let's talk about how PPI models generally work. Here is a cash flow diagram. You're probably used to seeing those in software engineering, right? Yeah, that's a cash flow diagram of how profit flows in pay-per-install network. Somebody, a shady guy, who we'll call Kingpin, sets up a website. On that website, he entices attackers to submit their malware samples, their malicious programs. And he says to them, attackers, if you pay me money, I will distribute the malicious software for you. Now, so Kingpin gets some money for distributing his software. On that same website, the Kingpin recruits other people who are called affiliates. Affiliates are people who are looking to make generally a quick buck. Now, sometimes they can be average Joes who are just looking to make a quick buck, or sometimes they could be very expert hackers who have compromised a lot of systems already. So, and they take the malware samples from the Kingpin and they plant the malware samples on vulnerable systems. Every time when they successfully infect the system, Kingpin pays them money. As you can see already, there is a motivation for affiliates to spread malware. Now, and the better the affiliates are doing their job at spreading malware, the happier the attackers are going to be. So if I'm the attacker, I give my malware samples to Kingpin, and then I look at the statistics like, oh wow, it has spread to millions of systems. This guy's good. Let me give him more of my malicious software. He's doing a pretty good job at spreading my malware. So, now, so let's look at another cash flow diagram. So, this one shows a practical example. One of the most common types of malware that is being spread out there is a fake antivirus. Anybody has ever got one of those? Do you know what a fake antivirus is? Just like the name implies, it's an antivirus that is fake. Back in 2012, when it was last time I looked at the statistics, there were 319 varieties of fake antivirus applications. That was 2012. The number has probably gone up quite drastically since then. So, fake antivirus are a very popular commodity nowadays. A lot of them are being spread by PPI networks. So, let's say I start an antivirus company, a fake antivirus company, that makes a fake antivirus. I give a copy of my fake antivirus to the Kingpin. The Kingpin, of course, I will pay money. He will then give copies of my malware to the different affiliates. Affiliates will spread that to victims. Now, what happens when the fake antivirus gets into the system of the victims? Yes, some people will be smart enough to get rid of it, but when you spread something to thousands or even millions of systems, what's going to happen? Someone's going to take the bait, right? Someone's actually going to pay for it. They will see the warnings come up, right, saying your system has 100 different infections. You know, people will get scared, they will pay for it, right? Guess where the money goes? Back to the attacker. Now, what does the attacker has more? He has more of cash now, right? He has more resources to develop malware now. This chain works. Alright? So, now, this slide just summarizes what I talked about, so you can refer to it later on. I will make them available through Dr. Choi. But here's an example of a fake antivirus. Okay? It looks very convincing though, right? I mean, it looks like a legitimate Windows pop-up. So, and it tells me I have all kinds of infections. So some people would actually pay for it. You gotta pay for it in order for it to, quote unquote, remove the infections. So the question is, if you wanted to join a pay-per-install network, you wanted to become an affiliate, how would you do it? Okay, once again, this is not an encouragement, this is a case study, okay? So, well, Kingpins recruit affiliates in all kinds of ways, ranging from underground internet forums. I'm sure you all know how to find those. There are plenty of them online. I'm sorry to say a lot of them happen to end in .ru, which is the country that I'm from. And no, I'm not part of any of those. So, yeah, people have asked me that. So, okay. Another one is word of mouth. Have you heard of this new cool PPI? I've been working for them for a month now. Look at how much money I made. I made 1,000 something bucks by just sitting at home and clicking buttons. Word of mouth. Another one is online classified ads. Yes, those people actually advertise online. And later on, we will also see how online advertising can be used for spreading malware as well. So online advertising. I'm sure you have seen those as well. Have you ever gotten emails or saw online ads which say, you know, stay at home and make a lot of money? A lot of those come from PPI networks. This is an attempt to recruit affiliates. Now, people say that don't buy for it, this is a scam, you won't make a penny. Well, no, it's not a scam, you will make a buck. The thing is, you won't be doing things that are ethical and quite possibly illegal too. So, alright? Now, also traditional methods. Yes, some people actually still post papers on the lampposts. This has merits as well, because if you post something on the lamppost, you're not leaving any online tracks. Because whatever you post online, Google remembers everything, right? So, well, Google hasn't gotten to the lamppost just yet. So, whatever you post on a lamppost, you know, paper trail is much easier to cover up. So, one of the biggest pitches for affiliates is make a buck, make a quick buck. for inexperienced people and for people who are desperate, this looks like a very appealing option. So here is one such website. Here is one such website. Now, I got this image from a white paper by Symantec. They haven't provided a URL for this website, and I think it's for a good reason, because they don't want people going there. So now, start making money now. Sign up now. And through a website like this, you can sign up. And no, it's not a scam. You will actually make money. You just won't be doing things that are legal and ethical. For some people, that's okay. All right? So, my mom, who's always looking, to make some money at home, she frequently sends me things like this, asking, "Is this legit?" So, yeah, I told her not to sign up for anything. Okay. Now, so I think by now we're pretty clear that PPIs provide a way to make money. Okay. So I can join a kingpin as an affiliate to make money. So let's say I join a website like this, and I start spreading malware, and I realize I made a little bit of money. What is the next logical step? I just done something, I made a little bit of money. What is the next thing I would want to do? Make more money, right? Make more money. Well, so, right now I'm working for one kingpin. How can I make more money with this? Work for multiple kingpins, exactly. And that's exactly what PPI affiliates do. They work for multiple kingpins. So, now, this has significant implications for your personal security. So, an affiliate who is working for multiple kingpins, he would collect malware samples from multiple kingpins, and what he can do is he can combine them all together into a single executable file using a program called a binder. A binder basically is a program which can be used for combining multiple executables together. Very often it's used for combining legitimate executables, such as Firefox executable you download from Mozilla website, and a malware executable. So you can configure it such that Firefox runs in the foreground, but in the background, a malware is running. So I can use a binder to combine multiple malware samples together, and whenever I infect a system, instead of one kingpin paying me, now I have multiple kingpins paying me revenue. You see what's going on here? The price per compromise goes up, right? The price per compromise goes up. So, one of the questions you may be wondering about, so what kind of malware is typically spread through PPIs? I think an easier question would be what kind of malware is not being spread through PPIs? But let's look at some of the examples. So once the affiliate signs up for a website, he gets access to the internals. And here is what a typical inside of a PPI website looks like. He can get access to malicious binaries. He can download them from those links. Yes, they're blacked out for a good reason, I'm sure. And he can also get access to malicious URLs. PPI networks, they don't just spread malicious binaries, they can also spread malicious URLs. I'm sure you got those too, right? You get an email saying, click on this link to see, something that you would really be interested in seeing, right? We'll see examples of that later on. So, when affiliates sign up, they get access to the inside of the website where they can download the malicious payload that they will be spreading around. Now, here is a breakdown from the study conducted by Symantec in 2009, which shows different kinds of malware that PPI networks are spreading around. So I have put descriptions of two of them, which are especially distracting. So one of them is Trojan Wando, a sophisticated features and payloads, including rootkit functionality, capability to download misleading applications by exploiting local vulnerabilities and extensions that encrypt files in order to extort money from the user. So that's a program which does all kinds of things, and amongst them is it will encrypt your files, it will delete your original files, and then say you want your files back, go to this website, pay this guy to purchase the decryption key so you can get your files back. Back when I worked in IT, I actually had to deal with this. There was a much more primitive version of worm going around back then called PGP Coder. It would basically do just that. It would encrypt your files and then ask for money. Fortunately, the implementation had a vulnerability, so the encryption was not quite perfect. So you could download the key from McAfee from Symantec, and you could actually get your files back at no price. But that was 2004, 2005. They've gotten much more sophisticated since then. Nowadays, probably it wouldn't be this easy. Another one is W3 by root. This one opens a backdoor to your computer and basically allows the attacker to manipulate your computer remotely, which includes downloading other parasites, attacking other systems, and doing all kinds of malicious activities from your computer. This pie chart shows other things, such as the Trojan horses that are legitimate-looking programs that have hidden features, implying malicious features. Downloaders, programs that download other programs. Trojan Mondo, that's the one I talked about. Fake alerts, all kinds of parasites. And the nice thing about it is if you get an PPI infection, you can get actually, as we talked about right here, multiple of those guys at the same time. Yeah. So, now, here is another way in which PPI websites help streamline distribution of malware. So, what happens to all malware eventually? The good guys eventually catch up and they develop countermeasures, right? They develop signatures, for example. I write a worm, eventually Symantec and McAfee will catch it, reverse engineer it, and develop a signature. Uh-oh, all my hard work was for nothing. So what do I have to do? I have to now modify my malware sample in order to defy detection, right? Now, once I modify it, I need to spread it all over again. That's hard work, but once again, that's where PPI websites come in. So what I can do is I can simply modify my malware and I can submit it again to the PPI website, of course for a fee, but the new executable that I submit becomes available pretty quickly to the affiliates. So the affiliates can take the new version of the executable and start distributing it within sometimes minutes. So you can think about it, it's almost like software maintenance and agile development, right? Right? Kind of sounds like it, right? I quickly respond to the changing requirements, right? I make the changes and I push them to the customer right away, right? Yeah. So most PPI websites update their malicious payloads every hour. So now malware distribution is also a robust process. So let's talk about pay rate. So how much are you going to be paid if you actually join a PPI network? Because after all, that's probably the first thing that gets affiliates in. Well, the pay rate per infected system depends on what country your system is in. So, based on this chart, who is the primary target? Who would be the primary target? If you're a PPI affiliate, which systems in what country would you be targeting most? US, right? Do you think there is a good reason for that? Like, why US? That's where most money is, right? The richest first world countries, right? US, Canada, West Europe. UK and Australia are not doing this bad either, right? So, whereas Asia is not, there is not that much profit in infecting systems in Asia. So, that's why affiliates try to target systems in those countries, because they get paid more for infecting those systems versus the systems in Asia. Now, so most affiliates get paid on a weekly basis. So every week you would get a, well, I should say paycheck. Most of them pay through PayPal and other online services. So PayPal, WebMoney, FedHard, and many others. There are other online services which specialize in transfer payment these days too. So let's look at an example. So here is a check stub of one of the affiliates. So in one day, he was able to install malware sample on 2,084 systems, and he made $555.08 in one day. That's one example. Here is another one. Now, this one is a Russian website, and you are fortunate because I can actually tell you what those mean. So loader, you can read that. The second column says setups. The third says buyers. I'm not sure what they mean in this case. The other one says returns, that's this column. This one is refunds, I'm not sure what that means. And this one is profits. So this chart shows how much money different affiliates can make. So here, one affiliate made $146,524.25 for installing a copy of SecureWorks, that's a fake antivirus, on 154,825 systems in a very short period of time.
So pretty much it's $1 per machine per installation.
What's that?
$1 per installation.
In this case, it looks this way. Yeah, in this case, it looks that
The
way.
other question is, what is the confirmation mechanism? Because if I pay you money, I want to know for sure the report, the correction,
Exactly,
right?
exactly. And we'll talk about that in a second, actually. Yeah, yeah. We'll talk about that in a few seconds. Yeah. Yeah. To answer your question. Yeah. To answer your question. So, yeah. Dr. Chen has raised a very valid question. So, if you're a kingpin, you're paying your affiliates. You want to make sure that affiliates are actually installing malware on systems, right? So how do you get a confirmation that the malware was actually installed? Well, when an affiliate is given a binary sample, that binary has an embedded affiliate ID inside of the malware sample. When the malware is installed in the system, so once I plant the malware in the system and once I activate it, the malware sample will call home to the server of the kingpin and transmit the affiliate ID. So, and the kingpin will update the payment statistics. Now, here are some examples of how IDs are being transmitted. So, what you see right here is an example of an HTTP request, which is a message that your web browser sends when requesting a web page from the server, and an HTTP response message, which is the message with which the server will reply when delivering a web page. So it looks like some sort of malware installer is using HTTP to talk back to the home server. And in this message, there is an affiliate ID embedded. It's like that. So to protect someone's privacy, I'm sure, right? So now the question is, where do they hide the ID? Because after all, a binary, right? You cannot just randomly start injecting stuff into the binary, you'll corrupt it. But they got pretty clever about that. So they would find parts of the binary that don't have any critical purpose, and that's where they would embed an ID. So here is one example. Most Windows executables, they have inside of them, they have code which prints an error in case you try running that executable in DOS mode. You know what DOS is, right? That was like way before Windows. Yeah. I think faculty in the room may have a better time remembering this than students. But all Windows executables have the code to print out the error message, okay? Saying you cannot run this program in DOS mode. So this message is not critical. In fact, it's rarely printed because people don't use DOS a whole lot anymore. So they would take this message and they would override it or partially override it with an affiliate ID. This is just one of the techniques, okay? So now, how do affiliates actually spread their malware? What is the process for spreading malware by the affiliates? Well, one method is file sharing networks. BitTorrent is a very popular one. So you would take a malicious executable, you would combine it with a legit executable, and you would spread copies of it on BitTorrent. But of course, you gotta play your game wisely. If you just upload an executable saying, hey, free malware, not many people are gonna go for that. So a common tactic which they use, and I'm sure all BitTorrent users in the room are probably familiar with it, they would give it an enticing name. And here is on the forum, so here's a forum where one guy is giving a tutorial on how to spread malware on BitTorrent. So it looks like he's suggesting a simple method to trick people to run your executable. Guess what executable they're talking about? They think it's an MP3, but it's actually an executable. And name it to some MP3 song from the top 20, like Rihanna Umbrella. Alright? You would have to name it something from the Beatles to trick me, but yeah. Powered by MP3 Bleach, yeah. Which is a reputable MP3 website. So, the downside of this method is that icon doesn't look like an MP3 file, but people will still run it. Now, so another approach is hacking into websites. Hacking into websites and injecting malicious code into the web pages. Because websites are visited by many people. You know how I said in the very beginning that PPI networks, they target clients, such as web browsers? Browsers have all kinds of vulnerabilities. So, hacking into a website and planting malicious JavaScript, for example, is a very good way to hook your, the fish. To hook your victims. Now, but they're a bit smarter than simply injecting straightforward JavaScript. They try to be clever. There are programs out there called JavaScript obfuscators. They basically would take your code and they would make it look something like this, without breaking the logic of the code. So your code will still work. It will still work. But the function names, the variable names, will be given this kind of, look. It's impossible to say what this program does. And you can download programs which obfuscate JavaScript. Don't use this as a cheating strategy on your assignments, okay? So here is the same code after it has been deobfuscated. And what this code does is it downloads malicious PDF files into your browser. Based on this, are you able to tell what the program does? No, right? But that's generally clear, right? All right. Another popular approach is the search result poisoning. Now, people make typos in Google all the time. You also can use Google Trends to find out what people are searching for nowadays. Now, you, as a guy who's distributing malware, you want to trick people into going to your website so they can download your malicious software. So, what they do is they set up websites and they give them Google search tags that match the top Google Trends, what people are searching for right now. Here's one example. At one point, during the US tax season, somebody has tagged their website with the tag federal income tax form. Get it? People misspell federal as feral. Yeah. And the first site to come up is an affiliate website, a PPI affiliate website. Yeah. One other interesting story. I teach PPI networks in my CS 456 class. A few people here have taken it. One student, he was studying for my midterm, so he wanted to learn more about PPI networks. So he googled up paper install services. He clicked on a link which seemed enticing, and that was actually, well, exactly what he was searching for. And within the same day, he got a call from the website on his cell phone, offering to enter some sweepstakes. And they were calling from the website. They probably got into his computer, stole his cell phone number, yeah, just by visiting a website. Just by visiting a website. So, another approach is malicious sponsored links. You'll know what, you have all seen those, right? As you're using Google, links come up which advertise things that are relevant to your search. So, what PPI affiliates do is they would pay Google to host their advertisements. Now, people quite often search for things such as the DirectX. DirectX is basically a Windows multimedia package. People who are using Windows may quite often need to update it in order to run some latest application. PPI affiliates know that. So, what they do is they pay Google to sponsor their links. So when somebody searches for DirectX, one of the affiliate links would come up. You would go to their website, And this website actually looks pretty legit. It actually looks pretty legit. You would download something that totally looks like DirectX, but when you would install it, you'd get something else. Right? Of course, the good old spam, right? I will send you an enticing spam email which contains a link to a trusted website. We all want to know how Michael Jackson died, right? At least in Spanish, of course. So, here is one such spam email. It looks like it's coming from YouTube, right? Ever got emails from YouTube? You see they're faking YouTube email format. And they're saying, you know, here is this enticing video. You can see how Michael Jackson actually died. So, you will click on it and it will take you to an affiliate website instead. Another one is mall advertisements. Have you ever visited a website where, you know, you're just there doing your business and then into your earphones blasts, you know, this something, would you like to save a bunch of money, you know? Ever had that happen to you? Yeah. Affiliates are pretty aware of those too. Websites that host advertisements can be used by affiliates. So, the affiliate would craft a malicious ad. Flash, JavaScript, they can all be used for attacking web browsers. So an affiliate would craft a malicious advertisement and then would pay an advertisement network to host that ad. Now, this way, legit websites may end up hosting malicious content because a single advertising network usually serves multiple sites. As a result, one time, New York Times ended up hosting an affiliate ad. New York Times is a legitimate website, so people trust it. So that's a great place for your ad to end up on, right? So to summarize, affiliates have basically mobilized every single way imaginable in order to spread their malicious programs. Now, let's talk about tools and aftermarket services. So if you're an affiliate, you need means to spread your malware. Like we talked about before, you're using spam, you're using BitTorrent, you are using malicious advertisements. Also, in the beginning, I talked about the binder program, which allows you to combine multiple executables together. Being an affiliate requires tools of the trade. Again, think like a business person. There is a demand, right? And wherever there's demand, there's going to be a supply. So another black market has grown up around this black market, which specializes in making tools and selling them to the affiliates. So, those are the different kinds of tools that are being sold to the affiliates. Now, what affiliates would do when they get paid by the kingpins, part of their earnings they would reinvest into buying better tools so they could spread more malware more efficiently. You can think of it as investment in capital improvement, right? Yeah. So here is an example of a binder program. So binders allow you to easily combine multiple executables into a single executable. So this one in particular allows me to drag in all the executables that I want to combine, and then I would just click build, and it would generate a single executable. When I would run the executable, all of those would be ran at the same time. So in this case, what it looks like the affiliate is trying to do is to merge all of those legitimate looking executables with some illegitimate ones. So notepad.exe, I guess, would be the legitimate one, PPI would be the legitimate one, but the rest would be malwares. In my CS4 physics class, students actually wrote their own simple binder, okay, just to see how those work. All right. Another one is packers. So packers are tools which affiliates can use in order to make their malware stealthy. So